Hey everyone, this is lesson 842 on arcs and sectors. This is an extension of the previous lesson where we've talked about area and circumference of a circle. So we're going to be looking at finding area and circumference of a circle, but maybe not the whole circle, maybe just a portion of it. Okay, so we're going to start with a common problem. And since we are talking about circles, um, talking about a pizza makes perfect sense for us. So uh, we are going to be trying to utilize these formulas. If you don't remember from the last lesson, area equals to pi r squared. So that's how we calculate the area of a complete circle. And circumference, also known as perimeter, can be calculated using 2 pi times r, right? In both cases, r represents our radius of the circle. All right, so in this problem, we have a pizza celebration going on. Girls ice hockey team has won the championship and has gone out for pizza to celebrate. And so we're going to be looking at calculating portions of pizza that have been eaten. So this first problem, we're looking at the goalie. The goalie ate half of a pizza with a 20-inch diameter. All right, so that information has been given to us. So the goalie, we're going to be talking about a couple different people here. And so one of them is the goalie. And we want to know really how much she ate. So we have an idea of the size of the pizza. It says 20-inch diameter. And let's start with visually. Right? Visually, we could see how much pizza she ate. It says ate half of a pizza. Right? So I've drawn in half of a pizza. And so if I ask the question, what portion of the pizza did she eat? Well, that information was already given to us, right? So we could say that the portion she ate was 1/2, right? 1/2 of the pizza. Now, if I want to know what was the area of the pizza she ate, right? So if we think of this slice, if she actually had a big slice, we don't want to find the area of the whole circle, right? Because she only ate half of it, or I don't know, maybe the other half, that the pieces that's missing. So how can we calculate that? Well, if we want to know just the piece that she ate, then we could find the area of the whole pizza, right? Because that's what we started with. And if we multiply that by the portion that she ate, in this case 1/2, then that should give us only the area that she ate. And on the same note, we're going to do the same thing with, if we want to know the length of crust she ate. All right, so the crust being on the outside, right? Crust is on the outside, which is, if you remember, the outside represents our circumference. So if we find the crust of the whole pizza, which is all the way around, and we multiply that by the portion, which was 1/2, then logically we would only get the crust, right? The crust that she ate. All right, so that's the general idea of what we're going to do. And so let's plug in all the information that we have and see if we could calculate this. Now, it does say that it was a 20-inch diameter pizza. So the one thing that you probably want to get out of this is, what's the radius? So the radius, what is that going to equal to if the diameter is 20 inches? So let's see if you could tell me that to get started. All right. If you think that the radius is 10 inches, then you'd be correct. All right. So now that we know what the radius is, let's start calculating the area. So area, right, which is really the area of the slice. I'll put slice. So we're going to start with a portion, which we said was 1/2. So we're going to have 1/2 times the area of the whole pizza. So the area, our formula, if you remember, was pi r squared. So I'm going to put this, let me change these parentheses to brackets. All right, so this is pretty much how we're setting up our problem. We said our radius was 10, so I'm going to plug in a 10 here. And that's pretty much the area of the slice. Now all we have to do is simplify that, and we could get an answer. And so area of the slice. So I'll leave the 1/2, and I'll start with the area of the whole pizza. So 10 squared is going to be 100 pi. Don't forget the pi. And now that we have that, now we could do 1/2 of 100. So the area of the slice is going to be 1/2 of 100 is 50 pi. Now don't forget the units on this. The measurement of the diameter was given to us in inches. So this is going to be inches squared. Don't forget the squared because we are talking about area. All right. So what we did was we just figured out how much pizza the goalie ate. We could convert that to a decimal, but for right now I want us just to focus on exact answers. All right, so let's see how much crust did the goalie eat. So we're going to do the same thing here. So the crust, and really it's the crust of the slice still, right? We're still talking about the slice. And so we're going to do 1/2. And instead of pi r squared, we're talking about circumference of the circle, right? Circumference goes all the way around. And so that's going to be 2 times pi times r, right? So r in this case is 10. All right, so if you don't remember those formulas, again, these are the same ones that I gave at the top. Make sure that you have those near you or copied down so that you could use them whenever you need to. So those are really the two formulas we're using right now. So when we simplify this, all right, so the crust of that slice is going to be, what, 1/2 of 20 pi. And so the crust of just the slice she ate is going to be 1/2 of 20, which is 10 pi. And this is going to be inches. So be careful here. These are, so circumference, the crust is actual inches. Like if you take the crust of your pizza and you straighten it out, you could actually measure it, and that'll give you some measurement, 30 something probably inches, and this is going to give us the actual area, the space inside. So make sure you know the difference. Area is going to be the actual where all the cheese and pepperonis and whatever toppings you have, the bread, and then the crust is just going to be this measurement on the outside, right? So be careful. Make sure you know the difference there. All right, and that's pretty much it. So that's kind of what you need to know. So we're going to look at a couple different situations. The first, or the next one, we have one of the other players, Sonia. She ate from another pizza with a diameter of 16 inches, and we also know her slice that she ate has a central angle of 45 degrees. All right, so we're going to do kind of similar work that we did on the previous part, except information is given to us a little bit different. So starting with how big the pizza is, right? Because they did tell us has a diameter of 16 inches. So that's going to tell us our radius is equal to, all right, let's see if you could tell me what that is. All right, if you said 8 inches, you'd be correct. Okay, now the next part is how much of the pizza did she eat? So let me resize this. All right, so now it doesn't say she ate half of the pizza. It doesn't say she ate any portion of the pizza. All it tells us is that her slice, assuming this is her slice, the central angle is approximately 45 degrees. So if you notice, even in the pizza, I put a little 45 degrees. So this angle in here is 45 degrees. Well, why did they tell us that information? Well, I guess the question for you is, if that's 45 degrees and you put in all the other slices, right? Maybe there was a bunch of other slices in here, and you add all those slices together, what would be the total of all those central angles together? All right, so if you add up all the central angles, it should give you 360 degrees. All right, so that means the portion that she ate, was 45 degrees out of 360 degrees. That's how much she ate. 45 degrees out of 360. So if this was if it was a percentage, right? And when we talk about percentages, we always do numbers out of 100, like 50 out of 100 or 45 out of 100. All right, that tells you how much of the whole someone has. But with circles, with angles, it's not out of 100. It adds up to 360 degrees. All right, so this will give us the portion of the full circle. All right, so let's use that information to calculate the area of her slice and the length of crust of her slice. So I'm going to set this up for you and then ask you to answer this as well. So the area of the slice is going to be, we start with the portion. So I'm going to put 45 over 360 times, and this is where we're going to have pi r squared. So instead of the r, I like to put the parentheses squared, and then that way I could just fill it in with the number I need. All right, so I'll even leave that right now for a second. And then the crust of the slice is also going to be 45 out of 360 times, this is going to be 2 pi r. All right, that's pretty much how you would set up this problem. Now all you have to do is plug in our radius, which we said was 8, to both of these. And that's pretty much our answer. All we have to do is simplify it and get a final answer. All right, so let's look. I'm going to zoom into one of these at a time. So how can we reduce this? Well, 45 over 360, most of the time this is usually going to reduce to a nice fraction. It doesn't have to reduce to a nice fraction, but many of the problems you see will probably reduce nicely. So one thing that you could try to do is in a calculator, you might want to see how many times does 45 go into 360. So if you take 360 divided by 45, if you actually flip it, you'll notice it goes in 8 times. So this actually reduces to 1 over, oops, let me use a different color. This reduces to 1 over 8. And then 8 squared is 64 pi. Oops. All right, so that then could simplify 64 divided by 8. Or, yeah, 64 divided by 8. And we end up with 8 pi unit, oops, not units, inches squared. So that's going to be the area of, this is area of Sonia's slice. So area of Sonia's slice. All right, so that should make the crust a little bit easier to calculate since we've already reduced 45 over 360. So the crust of the slice is going to be 1/8, right? Times 8 times 2 is 16 pi. And then that should reduce nicely. Is going to be 16 divided by 8 is going to be 2 pi inches. All right. So hopefully you get the idea. The work is very similar to what I did on the previous part. I'll go up real quick just to remind you. We're looking at taking the portion of the pizza times the whole pizza. All right, portion times the whole. And once you figure out what that fraction is going to be, then it makes it a lot easier. Okay, so as we move on, as the evening moves on, Sonia is still hungry, and Sonia decides to eat from the goalie's pizza. All right, so again, this is not the pizza that Sonia just ate from. This is the original goalie's pizza, which, if you remember, I don't know if you remember, what was the radius of the goalie's pizza? So let me see if you remember that. Maybe look back at your notes. So goalie's pizza, what's the radius of the goalie's pizza? Okay, so let's see if you got this correct. The goalie's pizza was, I actually don't even remember. So I'm going to have to look it up. So this is what I would have expected you to do, is to go back to the notes. The first problem we started with was the goalie's pizza, and it said 20-inch diameter, and we said the radius was 10. All right, so that means you should have answered 10, right? So 10 inches for the goalie's pizza. All right, so that means, and it was a central angle of 72, so the radius is 10, and her slice, a pretty big slice, 72 degrees for that one. All right, so let me ask you this. What portion did she eat? All right, what's that fraction look like? Based on the previous slice Sonia ate, see if you remember how we set up that fraction. You do not have to reduce it. I'd prefer if you didn't on this one. All right, so let's see if you got this correct. We're looking out of 360 degrees. we're going to say this is 72 over 360. So that's how much pizza she ate. 72 out of 360. All right, so we're going to use that information to calculate the area of this bigger slice she just ate and the length of the crust that she ate. So let's see, area of the slice. So I'm going to get you started on this one. So we're going to do 72 over 360. And we're going to do pi r squared. And then I'll help you out with the crust as well. So the crust of the slice is equal to 72 over 360 pi, going too fast, 2 pi r. All right, you'll notice it's setting it up the same way every time. I'm going to see, I'll stop here and see if you could finish the rest on your own. And then I'll ask you what the answer is. So what is the area of her slice? Okay, let's see if you got this correct. We're going to reduce 72 over 360. So let's do, I believe 72 goes into 365 times. So this actually reduces to 1 over 5. So this is 1 over 5 times pi. Oops, I forgot to put in my radius, which was 10. And so 10 squared is going to be 100. 100 pi. All right, so the whole circle is 100 pi. We want to multiply that by 1/5. So that's the same as 100 pi over 5. So you could, if for some reason it doesn't go in nicely, if you left your answer as 100 pi over, let's say it was 100 pi over 3, then it's okay to leave your answer as a fraction. So that's another possibility as well. So this one actually does reduce. 100 divided by 5 is 20 pi. Don't forget the pi at the end. That's still a part of the number. So don't forget pi actually represents 3.14156, and etc. We are looking at inches squared. So that would be our area. And then let's see if you could get the crust. How much crust did she eat on this slice? Okay, so let's plug in our 10, because that's our radius. And we've already reduced, I already know this fraction is going to reduce to 1 over 5 because we just did it over here. So that's the nice part. If you do it once, then you could reuse the same fraction. And then 10 times 2 is going to be 20 pi. So that means 20 pi over 5. There's a reason why I'm writing it like this, because there is going to be a time where this fraction does not reduce. So I would recommend always write it as one fraction first, and then if it reduces, reduce it from there. Because most of the time, like I said, if this happens to be a 3, most people make a mistake at that point because they forget they could just leave it as a fraction. So I would recommend setting it up as a fraction first and then trying to reduce it. In this case, 20 divided by 5 is 4, which means 4 pi inches, right? So keep in mind, this is not 4 inches. This is 4 times pi. So if you actually put this in a calculator, it's going to give you something like 12 point something, I believe. All right, so that is how we figure out the area of the slice and the length of the crust. So now that we kind of have an idea of how to do this, let me give you some proper terminology. So even though understanding it using pizzas is cool, you should know the proper names. All right, so when we talk about length of crust, what we're really talking about is arc length. So if I ask you to find the length of the arc, then I'm asking you to find the length of the crust. So this arc is really, it's a portion of the circumference. So we already know the circumference goes all around. So when we just take a piece of it, we call this the arc. And so if I want to know the length of that arc, then it's like finding the length of the crust. All right, so this is exactly what we just finished doing, except we're just giving you better names for these. And when we find the area of the slice of the pizza, we're really talking about a sector area. And so the slice that we normally see is actually called a sector. So if I ask you for the sector area, you should be thinking, okay, slice of pizza. If I ask you for arc length, you should be thinking, okay, length of the crust. And that's the outside. All right, so if you don't need to remember it in terms of pizza, then that's perfect. But if the pizza idea helps you, then by all means, I really hope that you use that to help you. And so there's no like technical formulas for these, so I've just kind of put together one for us. And so I'm calling this is a cursive L. I'm calling L as in length. And so if we want the length of the arc, then we would take portion of the circle, which we talked about earlier. In this case, it's going to be theta, whatever the angle is, over 360. All right, it's always going to be some angle over 360. If you want the whole circle, then this would be 360 over 360, which is perfect because then it reduces to 1. So even if anything, you should remember these formulas and not the traditional 2 pi r and pi r squared, because these will work for both. So circumference of a circle is still something you should know, and area of a circle, formula pi r squared, is there as well. You'll notice the portion is the same for both of these. So crust and slice, or arc and sector. Right. So that is, I believe that's it. So that's kind of a summary of what you need to know. So in the next lesson, we're going to be practicing a little bit more complicated problems. But anytime you come across sector area, this is the formula they're expecting you to use. The nice part is that I really like these type of problems because it's a lot simpler. All you need to know is the radius, which is awesome, one number, and the angle, right? So if you know the angle, and if you don't know the angle, maybe the problem will tell you, like the goalie ate half. So then you just have to put 1/2 here. So that's another way of doing it as well. All right, let me know if you have any questions. And that's it for now.